So in this problem, we want to find the area bounded by these two functions, this quadratic for f of x and this exponential function for g of x, and the lines x equals 1 and 5. So the first thing we need to do is get a picture. So I graphed those two functions here on Google real quick. The blue one is the parabola, the red one is the exponential. So if you're looking between x equals 1 and 5, zoom in a little bit here. 1 is right about there. Clearly the blue function, the quadratic, is above or on top, and then x equals 5 is right about here. So the quadratic is above the exponential function for the entire interval between x equals 1 right here and x equals 5 right here. So when we find the area between them, what we're actually finding is, I'm going to shade it in, here real quick. Okay, so what we're actually finding is roughly this area in here between those curved shapes. So when you're finding area like that, it's always the top function minus the bottom function, and we're going to integrate from x equals 1 to x equals 5, which I previously already worked out. So this is the f of x minus g of x. If g of x had more than one term, we would have needed parentheses right here, but it only has one term in this case. So then we anti-differentiate x squared to get a third x cubed, negative 3x to get minus 3x squared over 2. Antiderivative of 15 is 15x, and the antiderivative of negative 0.6 e to the 0.6x, the constant 0.6 actually stays out front, but you don't see it here because you also multiply by 1 over this coefficient of x. So 0.6 over 0.6 cancels, and you just get that coefficient of 1 right there. Times e to the 0.6x from 1 to 5, so you plug in 1 minus, or plug in 5 minus, plug in 1, and then simplify as much as you can, and go from there. And it's possible that I did not finish writing it out right there. There should be some exponential terms that I left off. So I don't think I finished the problem when I worked this, so I'm going to say plus dot 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 to be continued. But anyways, that is how you find the area between those two graphs.